Hi everyone, in this video we're going to go over another Leetcode question, remove duplicates from sorted list 2. Major tech companies like Google, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Given a sorted linked list, delete all nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. Example 1, 1, 2, 3, 3, 4, 4, 5. And we remove all the duplicates, leaving only distinct numbers, and return it sorted as well. Example 2, 1, 1, 1, removed. 2 and 3 remains. And we return 2 and 3 in sorted as well. So let's get on the whiteboard and try to solve this question. So, like in many questions where we need to remove duplicates, find duplicates, etc., we use two-pointer approach. And in this question, we're going to use two-pointer approach as well. We have a slow node and fast node. We create two nodes, slow and fast. And in linked list questions, we use dummy nodes. This is to keep the reference to the head node. For example, during the question, if you lose track of the head node, in the end, if you say dummy.next, that means the reference to the head node you keep in the beginning. So that's why we use dummy. The list node value, in this case 0, -1, you can put anything. You can put 400, doesn't matter. So, excuse me. So in this case, dummy is keeping a reference to the head node. That's the idea. We place it before the head, and that points to the head nodes. Slow, so dummy.next is actually a head node, right? So what we do here is fast is head. We place the fast node here, fast pointer. Dummy pointer is slow. We place the slow in the dummy pointer, and set slow.next to fast. Slow is pointing to fast. Then our while loop begins. The fast node will go through the list one by one, and it will skip this duplicate nodes. We have a 3-step check here, and we need to remove duplicates as we see. So while fast is not null, okay, fast is not null, start iterating. 3 checks. First one, fast is next not null. That means fast is not the next, not the last node, and fast step value is equal to fast step next step value. Okay, so in this case, fast step value is equal to fast step next step value. This means find the duplicate. If this is a duplicate, implement this. So in this case, this is not a duplicate. So we are passing this. We are not implementing this. So next step. Slow.next, is that equal to fast? Is there a gap between slow.next and fast? For example, in this case, there's a gap. Slow.next is not equal to fast. But in our case, we skip this step as well. Slow.next is not equal to fast. Fast is wrong. So we implement else. This means literally, if there is no duplicates, simply move slow and fast nodes. Fast goes one step ahead, right? Excuse me. And the job of fast node is it will skip the duplicates, and slow simply will follow the fast. That is the logic here. Don't memorize this. Just understand the logic, then it will be quite simple. So we continue. Fast. Then while fast is not null, that is fine. Fast at next is not null, that is the case. Okay, the fast is next is not null. Fast at value, fast at next at value. Fast at value is 2. Fast at next at value is 3 is not equal, so we skip the first step. First step is another while loop. We skip it. Slow.next is not equal to fast. Now slow.next is equal to fast, so we skip this as well. So basically this means these are not duplicates. So move slow and fast pointers one step. Here's where interesting part begins. Right. Another iteration, iteration 3. We are in one iteration. We are doing all of them in one iteration. Don't just forget that. So while fast.next is not equal to null, yes, it's not equal to null. Fast.value is equal to fast.next.value. That is the case. Move fast 1 point. So actually, I will put it in a minute. Excuse me. So again, we are inside this while loop. Fast.next is not equal to null, yes. Fast.value is equal to fast.next.value, no. Keep it here. The first step check is done. We are still in the same iteration, okay? Slow.next is not equal to fast. That's the case. There's a gap now, if you see. Then what we do is slow.next, fast.next. So place slow and fast in the same place. And fast, slow.next. And move fast 1 point. So what happened now? Fast skipped these nodes, right? So these are done. Okay. So we are still in the same iteration. In one iteration, we were here, then we just passed them, and we are here. In the next iteration now again, fast.next.null. Yes, fast.value, next.value, that's right. Move it. Again, in the same while loop, we are still in the same iteration here. Fast.value, fast.next.value, that's false, so we skip this step. Now there's next step to implement. We have a gap here. What do? Slow comes to fast, slow.next, fast.next. Now slow and fast, same place. Move fast 1 step. So what happened? We removed these duplicates. Okay. And what is the case now? Fast is not equal to null. That's the case. Fast.next, is it equal to null? Yes. Skip this step. And slow.next is not equal to fast. Now slow and fast next to each other. If there's a gap, we use it. So skip this step as well. So we simply move fast and slow. So as you see, fast and slow now, iteration is done. So all we do is now we have a new linked list, and we'll simply return dummy.next. That will give us the reference to the head of the new linked list, right? So let's see this in the code. Again, this node created, head, fast, slow, slow.next, slow and next is linked here, so that we can check if slow.next is fast. That's what we do here. And do the first step, do the second step, and do the third step, and finally return the reference to the head node. Submit. This works, and this is pretty much it for this question. I hope you found this video helpful, and I have more videos coming up. So if you subscribe to my channel, we can meet again in the near future, and please don't forget to hit the like button as well. Thanks for watching. Goodbye.